Hello and welcome to this hands-on session on normal distribution using Python. In this session, we will learn two things. Point number one, we'll learn how to calculate the probability under a normal distribution for any event from z-score. And the second thing which we learn today is exactly the flip of point number one, which is calculating the z-score using the probability of a given event under a normal distribution. So let's jump directly into it using Python. Now, this is my Jupyter notebook in which I have already written down the entire code, and we'll do this understanding, or we'll try to understand this using a good complete case study. For now, let's understand the two functions which we'll be using in order to achieve these 2 points I've just spoken about. So at the first step, or in the first cell, I import all the libraries, the first one being pandas, numpy, and then SciPy.stats, which gives me the functions which will help me to achieve the probability or the z-score. So the two functions are CDF, which is nothing but cumulative distribution function, and the second one is PPF, which is exactly the reverse of the CDF function. The full form of PPF is percent point function. Now, what do these two functions do? So let's say I have this normal distribution. And I want to calculate the probability under this normal distribution given a z-score. So if I have this as mean, and I want to calculate a probability of any event occurring with this kind of a data distribution. So let's say I want to calculate the probability of this event occurring. Now, how do we define this event? Maybe I define this event with some x value, which is nothing but the value of the random variable on the x-axis. And we take a corresponding z value, which will give me the probability of this event occurring. Now, what does probability means? It means nothing but the area under the curve towards the left side of this event. As we know that the entire area under the normal distribution or under this distribution is 1. So the probability in this case would definitely be less than 1. And this probability in Python can be calculated using this CDF function. So for instance, in this first point, if I want to calculate the probability under normal distribution for a z-score of 1.2, I simply give 1.2 as an argument to CDF, which will eventually help me to figure out this area under the curve. Now let's get the answer for this. And the answer for this is 0.88, which means if an event with this kind of a z-score of 1.2 is occurring, that means the probability of that event occurring is extremely high. It's almost 88% chances that that event would occur. Now, the flip side of this could be, give me, if someone tells you that, okay, give me a z-score for which the probability is maybe 88%, So in order to calculate the Z score corresponding to this 88%, I use another function, which is PPF function. Now let's use this function to calculate the Z score. So in this case, he's asking calculate the Z score for 0.25 probability under normal distribution. So if I execute this, I get the corresponding Z score for 0.25 probability. Now let me just check my answer for this 1.2 Z score. So if I give a probability of 0.88 to the function PPF, it should return back 1.2. So let me just use this function once again, and let me give the value of 0.8849, and let me see if I get a Z score of 1.2. Yes, I do get it. Very, very close to 1.2, which is 1.1999. So if I give the entire value of 0.88493039, I would get a value very close to this 1.2. So I'm able to confirm that yes, PPF and CDF are the inverse functions to each other. Now, another point which is worth mentioning before I actually move to the case study is that this CDF function needs Z score as the input or as the argument to CDF. So in CDF, whenever I'm using the CDF function, the argument to this CDF function is a Z score and not a X value. So what I need to eventually do is, so for all those who want a quick revision of the difference between Z and X, let me just open this slide quickly and let me just explain. So X is a random variable which defines your normal distribution. And if I want to calculate the Z from this X, all what I have to do is just use this formula of X minus mu. Mu is nothing but the mean of this data distribution, and divided by sigma, which is nothing but the standard deviation of this data distribution. So with this formula, I can juggle between the random variable X or the normal distribution and the standard normal distribution, whose axis at mean, the value of Z at mean is 0, and then towards the right side it goes towards positive, and towards the negative side or the left side it moves in the negative direction. So let's move back to our problem and let's see what it means. So this basically means that given this 1.2 Z score, if let's say I had an X value corresponding to this and not a Z value, all what I had to do is I had to convert the X value corresponding to this into the Z score and then feed it to my function CDF. Similarly, this PPF function, whenever I'm giving any probability value to this as an argument, it returns Z score and not my X values or the random variable values. Does that mean that every time I am giving an argument, I have to manually calculate Z score and then feed it to the function? No. Python makes it very simple for us. All we have to do is, in this case, we can simply give our X values, then we can give our mean, and we can give our standard deviation, which would again calculate at the back end, it would calculate the corresponding Z and then give you the probabilities as the return value. Similarly, while I'm using PPF function, if I want to directly get as a resultant, I want to get X and not Z. I don't want to get the Z values, but I want to get X values. All I have to give is the probability value, the mu, and the sigma. All right, so with this understanding, let's move into the case study and let's try to understand how to use these functions to get a better sense of the business problems or get a more intuitive understanding or try to answer the questions of different events occurring and what kind of probabilities do different events carry with them. So for this, I have a simple data which corresponds to a data science training institute. Now, in this institute, the learners have that flexibility to learn data science at their own pace through self-learning program. Now, since it's a self-learning program, so of course, the pace of learning or the amount of time taken by different learners would be different. Now, assuming that this time which different learners are taking to successfully complete this program is normally distributed, we need to solve certain problems based on this data. So I have 4 sets of problem number 1, problem number 2, problem number 3, and problem number 4, which would give me a good hang of this entire PPF and CDF functions and how to calculate the probability and get the Z scores. Now, the characteristics of any normally distributed data is defined by mean, which is depicted by mu, and standard deviation, which is depicted by sigma. So here as well, we have these 2 numbers, which is the mean is 100 hours and the standard deviation is 20 hours. So after I read this data from this CSV file, I take the mean of this data. Now, this data is about all those 200 odd learners whose number of hours to complete this training program is captured. So I take the mean of all these 200 hours, I fetch it into a variable called mu. Similarly, the standard deviation is taken in this variable sigma, and then I use both these variables in the subsequent code. Now let's start executing all these one by one. So I've already executed and captured the data into the variable data. I'll get the mu and the sigma, and then let me quickly plot this data to figure out how the data is being distributed visually. Now, if I look at it, it's very close to normal distribution, although not exactly normal. And the main reason for this is because I have limited data. So while it's not an ideal normal distribution, but it's very close to normal distribution. And for all practical purposes, I'm taking it as normal distribution. Now, given this data distributed in this manner, let's try to attack all these problems one by one. So problem number 1 says, what is the probability of a learner? What is the probability of a learner taking more than 100 hours to complete this program? Just hold this video for a moment and try to answer this in your head, that visually, what area does this question ask us to calculate? So what this question is saying is that what is the probability of a learner taking more than 100 hours, which essentially means he's asking us to calculate this area above 100 hours. Let's figure out how to do this using Python. Of course, I know that the answer to this question would be very close to 0.5. And what is the reason? The reason being very simple, that the total area under the normal curve is 1, and the mean of the norm of this normal curve is 100 hours. The standard deviation is 20 hours. And the question says that what is the area beyond 100 hours? What is the area under this normal distribution beyond 100 hours? Which means approximately half the area, which stands as 0.5. But then let's try to understand programmatically how to solve this. So we'll make use of CDF function. We'll make use of CDF function in order to calculate this. So what I have done this over here is I have subtracted the value of CDF from 1. Why have I done this? For a very simple reason, which is whenever we are using CDF function, it starts calculating the area under the curve from the left side. And according to this question, it's asking me to calculate the area under the curve towards the right side of the 100, which means when I give the x value of 100 to CDF, the function would actually calculate this area. Whereas I'm looking the area towards the right side. And since the total area under the curve is 1, in order to capture this area, I subtract this area from 1. Now let's see, is my answer close to 0.5? Yes, it is. Very much close to 0.5. Let's check the next problem. Now, the next problem says, what is the probability of a learner taking between 130 and 150 hours to complete this program? Again, I would request you to pause this video and just in your head quickly shade that area which we are trying to capture through this question. Now, the area which we want to calculate this time is this area. And for this, what I have to do is I have to simply do CDF 150, which would give me this entire area, which would give me this entire area towards the left side of 150. And from this, I would simply subtract CDF of 130, which would give me this area. And this means essentially I'm just left with this much area. So let's try to see if we are able to capture this area using our functions in Python. So CDF 150, mean and sigma are given. Subtract CDF 130, mean and sigma are given. And the area we get is 0.05, which is 5%. Now moving on, the next question in the series says, what is the probability of a learner taking less than 40 hours? So the question asks us to calculate the area under the curve below this point, below 40 hours. And imagine how small this area would be, extremely small. As a property of normal distribution, we already know that more you are nearer to the mean on either side, more the probability of that event occurring. And in this case, the question asks us to calculate the probability of a learner completing the course within 40 hours, which means it's asking us to calculate this tiny bit of area under the normal distribution. So let's calculate this area using my CDF function. And as expected, the area comes out to be very, very less, which means the probability of this event occurring, this event of a learner completing the entire program within 40 hours is 0.0006, very, very tiny. Now with this, we are able to cover the CDF function. And the final question would capture the flip side of what we have done so far. Now this question says, within how many hours do fastest 15% of all the learners complete the program? So basically he's asking, given the probability of 0.15%, calculate the z-score or the corresponding number of hours. Now, since the PPF function would return z-score, but we give the value of mean and sigma, and thereby the final answer we'll get is in number of hours or the exact value of our standard or of our random variable. So in this question is, let's do this programmatically. So I give 0.15 as the probability value or the first argument to the PPF function, which would eventually give me the x value. And the x value I get is 81 hours. So what does that mean? This means, if I have to visually interpret this, this means that the top 15 percentile, the top 15 percentile of all the learners who are attending the program are able to complete the program within 81 hours. So with this, I hope you are able to understand how to juggle between calculating the probability of an event under normal distribution and how to calculate the value of a random variable given the probability of that event occurring. Thanks for watching this video. I hope you enjoyed it.